Hi, this is Dr. G. Vikas Paul. In this session, we are going to discuss a problem on a rectangular section and how to find the stresses at the corners of the rectangular section. Okay, right. So calculate the stresses at the corners of the rectangular section. Okay, this is a rectangular section. This is a beam. Rectangular section of a simply supported beam of span 5 meters, which carries a load of 4 kilonewton at the center of the span. So there is a simply supported beam at the center. There is 4 kilonewton. Okay, this is side elevation. This is actually inclined. Okay, the load is inclined at an angle of 30 degrees to the vertical longitudinal plane. Load is inclined. Okay, this is front view. Through this front view we can see this rectangular cross section, and through this in this front view only we can see the inclined load 4 kilonewton. Okay, this is inclined 4 kilonewton. It passes through the centroid and the angle is given as 30 degrees with y axis. Okay, so we need to find the stress as and passes through centroid. The dimensions are shown in the figure. So dimensions is, if it is A, B, C and D, this is 40 mm and height is 50 mm. Okay, angle is 30 degrees, load is 4 kilonewton. Okay, xx y5. Now we need to find the stresses at A, sigma B, sigma C and sigma D. Okay, so as it is symmetric about xx and yy, we can write uu and vv. Okay, right. Now we know that given section is symmetrical about xx y axis, so product of inertia ixy will be equal to 0. Hence xx y axis will be the principal axis, that is UUVV. The center G of the section is at the center of the rectangular section. Right. Now we need to find sigma A, sigma B, sigma C and sigma D. Stress at this point, stress at B, stress at C, stress at D. This we need to find. We know the formula, that is sigma equal to m1 by ixx into y plus m2 by iyy into x. Okay, this is the, let this be equation 1. Now what is m1 here? M1 M2, let us calculate M1 M2 first in this formula. So if it is M, that is, this is load, this W, M is a moment. Okay, bending moment, maximum bending moment. Okay, so if it is theta, this will be M1 equal to M cos theta, M2 equal to M sin theta. Okay, M1 equal to M cos theta, M2 equal to M sin theta. Now what is M here? So for simply supported case, subjected to point load at center, M equal to maximum bending moment is, we know the formula, WL by 4. So W is 4 here, L is 5, W is 4. Okay, L length is 5. So 5 kilonewton meter. Okay, so convert it into Newton mm. So M cos theta 5 into 10 power 6. Convert kilonewton to Newton, meter to mm. So 10 cube into 10 cube, 10 power 6. Cos 30, we will get this one, M1. M2 sin 30, M sin 30. Okay, now next ixx. How to calculate ixx? This is completed, this is completed. How to calculate ixx? BD cube by 12. Now what is I for rectangular section? Moment of inertia, BD cube by 12. So B is 40, D is 50. 50 cube by 12, this is ixx. What is iyy? dB cube by 12. So reverse, 15 to 40 cube by 12. This is iyy. This is over, this is over. Now if we substitute everything here, we will get this equation as sigma equal to 10.4 y plus 9.37 x. Let this be equation number 2. Now, yeah, see here, when there is an inclined load on the rectangular section, what happens if let this be the neutral axis. Okay, as of now we don't know what is the angle here. Okay, but there is a neutral axis, we know. Whenever a beam is subjected to a load, there will be deflection. We know this. And above the neutral axis, it is subjected to compression. Below the neutral axis, the beam is subjected to tension. Okay, compression above neutral axis. This portion is completely, okay, this above portion is completely subjected to compression. Below portion is completely subjected to tension. That's why compression we are taking the x and y axis as negative. Okay, above the neutral axis we are taking minus minus. Below the neutral axis, as it is subjected to tension, we are taking this y and x as positive positive. Clear? Minus minus plus plus. Now we need to substitute the values. What is the formula? What is the equation? This is the equation, right? Here x and y values, for each point we need to substitute the coordinates of x and y. Okay, now let us see the A. sigma, calculate sigma a. To calculate sigma a, we need to substitute x as x, we know that it is 40 by 2, that is 20. Y, we know that it is 50 by 2, it is 25. The values will be same for all, but the sign conventions will change. Okay, now here, where is a? It is in this quadrant, first quadrant. Okay, first quadrant, what we have taken in the sign conventions, minus, minus. So minus 20, minus 25. So substitute x equal to minus 20, y equal to minus 25 in that equation. In this equation, we will get it as this one. So stress at A is minus 447.4, minus, therefore compression. Okay, then next, sigma B. Where is B? Fourth quadrant. That means here it is minus x equal to plus 20, y equal to minus 25. 20 minus 25. Okay, next, so this will get minus, so compression. C, it is in third quadrant. So x is plus 20, y is minus 25. Sorry, plus 20 plus 25. Okay, plus 20 plus 25. Substitute, will get this one, plus, therefore tension. And here also x is minus, okay, and this is plus. So minus 20 plus 25. Substitute in this equation. Okay, then we will get this one, right? So stresses are calculated. Now we want to know where is the neutral axis, what is the angle. For that, the condition is stress should be 0, that is 10.4 y plus 9.3 sin x equal to 0. Then we will get this equation. Okay, y equal to minus 0.9x, which is the equation of a straight line, like y equal to mx, where m equal to minus 0.9. Okay, m small m. So m is nothing but a tan alpha, slope. So slope equal to minus 0.9, alpha equal to tan inverse minus 0.9, which is equal to minus 42 degrees. So this will be the neutral axis angle, 42 degrees, alpha equal to minus 42 degrees, minus 42 degrees. Okay.